All right, Mr. Ahmed here for section 1.3, part 2. Today we're going to work in the coordinate plane and use the midpoint and the distance formula. The midpoint is the halfway area between 2 points. And if we have two ordered pairs, keep in mind, ordered pairs come in the form x, y. So when I plot a point, for instance, just a brief little recap, if I have the point, let's just say 3, a little bigger, comma, 2. For me to plot the point 3, 2, x is 3, so I'd go right 3 and up 2. Okay, so 3, 2. And we're going to take 2 points and find the halfway point. In order to find the halfway point between 2 points, the formula is x1 plus x2 over 2 and y1 plus y2 over 2. So I'm going to have two ordered pairs. The first one's going to come in the form x1, y1. And the second point is x2, y2. And that's where we get x1 from, x2 from, y1, and y2. So it doesn't matter which one's point 1 and which one's point 2. You can switch up the order there however you'd like. We just need to plug them into the formula to find where the halfway point or the midpoint is located. So our first two examples, fairly straightforward. It's just going to give us 2 points. I have point K and point H. I'm going to find the midpoint M. So I'm going to let the first point be point 1. So negative 9 is going to be x1, and 3 is going to be y1. 5 will be x2, 7 will be y2. So I labeled out what's what. Now I just need to plug it into the midpoint formula. The midpoint, let's see here. The first value for x1 is negative 9 plus x2, which is 5 divided by 2, comma. There's a comma between the x and the y. Y1 is 3 plus y2, that is 7 divided by 2. Now I just got to simplify that down. So negative 9 plus 5 is negative 4. Negative 4 divided by 2 is negative 2. So the x value of the midpoint is negative 2, and that's point M. Y value, 3 plus 7 is 10 divided by 2, that is 5. So I found my midpoint at the point negative 2, 5. All right, one more example here. This time my two endpoints are W and T, just need to find the midpoint M. So x1, I'm going to put it above this time, y1, x2, y2. Make sure you don't label x1, x2, all right? The points come in the form xy, xy. That's a common mistake that we will see. So plug it into the formula. Midpoint is x1 plus x2, so negative 12 plus negative 8 divided by 2. Make sure you do the top before you divide, comma. Y1 is negative 7 plus negative 4 over 2. Now we just got to simplify it down. Negative 12 plus negative 8 is negative 20. Negative 20 over 2 is negative 10. And negative 7 plus negative 4 is negative 11. And negative 11 divided by 2 is negative 5.5. I'm going to put it as a decimal for plotting a point rather than a fraction. Either way would be fine though. And we found our two midpoints. All right, the next two examples are a little bit more difficult. All right. In this case, I am given a endpoint and a midpoint. E is the midpoint. We are supposed to find the other endpoint of the segment. So in this example, I'm just going to draw a very rough sketch of a graph just to explain how this is working. So if I draw out the graph and plot the points, point F is at 5, 8. So I'm going to go right 5, up 8. That's pretty approximate. I'm just going to label it. Point F is at 5, 8. And point E is over 4, up 3. So somewhere like right in here. All right. E is at 4, 3. So if E is the halfway point, that would mean our segment needs to keep going downwards somewhere, I don't know, right around in there. We have to figure out where. In order for us to figure out where, our pattern needs to be the same, going both directions. Okay, so we need to end up down here somehow. So when I look at the x values, for me to get from E to F, I went over 1. And I went 1 to the right. 4 to 5 is 1 unit away. So I need to go 1 unit away from 4 to the left, which would put me at positive 3. Okay, 4. 1 greater is 5. 4. 1 less is 3. Now for the y values. For me, I am 5 units up from 3, so it's 5 units away from this midpoint, and it's higher, so I need to go 5 units lower. So 3 minus 5 is negative 2. I have found the other endpoint, and that other endpoint was point, looks like we had F and E, we needed D. So D is at 3, negative 2. Now without the graph, you can do it without the graph as well. I'm going to circle my midpoint. Okay, that's where I know I'm at. When I look at the x value, the midpoint's at 4, the other one's at 5, so that's 1 bigger. I need to be 1 less than 4, which is 3. When I look at the y values, the midpoint's at 3. The endpoint that I'm given is 5 bigger. To go the other direction, I need to be 5 smaller. So 3 minus 5 is negative 2. So on the next example, I'm not going to draw a graph. I'm again going to circle my midpoint, and my midpoint is point E. And I went from 1 to negative 3, so that got 4 smaller. Opposite is 4 bigger. 4 bigger than 1 is 5, so that's my x value. And then my y value went from negative 2 to negative 8. That's 6 smaller. I need to go the opposite direction, which is 6 bigger. 6 bigger than negative 2 is 4. I have found my other endpoint, and in this case, it was F. You might see 1 or 2 of these. Drawing out a graph always makes it a little bit easier to see which direction you're going. Choice is yours. Last goal for today is to use the distance formula. And the distance formula is derived based off the same thing. I'm given 2 ordered pairs. The first one I'm just going to let be x1, y1. And the second point is x2, y2. Okay? And we're going to plug it into the formula. Just have to substitute it in and simplify. We're going to keep it in simplest radical form unless otherwise stated. So we are going to have to simplify the radical. All right, so we're going to hop into the first example and just substitute into the formula. Make sure we can see the formula at the same time. So first point, x1, y1. Second point, x2, y2. Substituting it in, the distance between the 2 points is equal to the square root of parentheses. x2 is 5, so 5 goes in for x2. Minus x1 is negative 7, so we have 5 minus negative 7 squared. Now, minus and negative is going to change to a plus. Okay, so we'll have to be careful when we simplify. In between the parentheses, a plus, parentheses, y2 is 9, minus y1 is 0 squared. Now we just need to simplify. 5 minus negative 7 changes to a plus, so that is 12. So I have the square root of parentheses 12 squared. Plus 9 minus 0 is 9. Again in parentheses, 9 squared. All right, 12 squared is 144. Plus 9 squared, that's 81. When I add those two together, 144 plus 81 is 225. So I have the square root of 225. That is indeed a perfect square. So I'm going to take the square root of 225, and I get 15. So the distance is equal to 15. That turned out to be a nice whole number. Next one, same process. Label out the points. x1, y1, x2, y2. Plug it into the formulas. Distance equals square root, parentheses, x2 is 4, minus y1, that is, or sorry, x1 is 1, squared, plus y2, 2 minus 5, squared. All right, now we just need to simplify it down. Square root, parentheses, 4 minus 1 is 3 squared, plus 2 minus 5 is negative 3 squared. Keep in mind I put that in parentheses. When you square these values, a negative squared, a negative times a negative is going to be a positive. If you end up with a negative after you squared it, you made an error. I just want to show you one thing here on the calculator. If I were to type negative 3 squared without parentheses. It says it's negative 9. Okay, that's because it's going to take 3 squared and multiply it by a negative. Notice our negative 3 is inside parentheses. We're taking negative 3 times itself. You need to put it in parentheses just like it is in the problem, squared, and it will be positive 9. So those parentheses are vital. All right, finishing up the process. 3 squared is 9 plus negative 3 squared is also 9. So we have the square root of 18. Now we need to simplify the radical. Perfect square factor that goes into 18 is 9. Square root of 9 times square root of 2. Square root of 9 is 3 times the square root of 2. We have simplified the radical to 3 times the square root of 2. Okay? All right. L to M. So I have to actually label where point L is. L is at negative 1, 2, 3, 4, 5, negative 5, negative 1. X1, Y1. M is at 1, 2, 1, 2, 3, 2, 3. We'll let that be X2, Y2. Plug it into the formula. Square root, parentheses, X2 is 2 minus X1, negative 5. So 2 minus negative 5 squared plus 3 minus negative 1 squared. All right, 3 minus negative 1 squared. Let's see here. 2 minus a negative changes to a plus. So that's the square root of 7 squared plus 3 minus negative 1 changes to a plus. So that's 4 squared. 7 squared is 49 plus 16. And 49 plus 16 is 65. So we have to find this perfect square factor that goes into 65. And let's see here. What goes into 65? I mean, like we said, you have to actually take out your calculator and start checking. I don't know of one. The closest one I can think of is 8, but 65 divided by 8 doesn't work. That's 64. Yeah, nope. All right, 65 divided by 7 is a no. Oh, sorry. I said bad move. I don't know why I said divided by 8. 8's not a perfect square. I was thinking of 8 squared. So backtracking here. 65 divided 36. Perfect square? No. 65 divided 25. No. 65 divided 16. No. 65 divided 9. No. 65 divided 4. No. There is not a perfect square factor that goes into 65. We're leaving it. It's the square root of 65. So that one did not simplify. Well, I should put my distance equals. All right, last one. Given that the length of A to B is 10 and point A is located at 4, 2, find a possible location for point B. Well, I'm just going to go X 10 units to the right. So if I just move X 10 units to the right, I would just have to add 10, and I would say 14, 2. That would be a possible location for point B. That would be a horizontal line. It just moves straight over 10 units to the right. Could have also added 10 to the y as well and picked the point 4, 12. Could have subtracted. Tons of options for this. And that's all we have for today. Have a good one.